Hey guys, how are you guys today? Today I'm going to be teaching for simple harmonic motion in terms of energy. And I'm going to start off by reading this problem. A block of mass m equals 2.0 kilograms is attached to an ideal spring with a spring constant of K equals 500 Newton per meters. The block is disturbed from equilibrium as a force acts on the block, resulting in an initial speed of 2 meters per second. Find the resulting amplitude. Okay, I'm going to start off by listing this equation. And if you are not yet familiar with this equation, all this equation is simply saying that for a spring that ensues a simple harmonic motion, the potential energy is going to equal to 1/2 K times the distance from the equilibrium position. And in this case, it's the amplitude, because that's what we want to solve. Usually it's 1/2 kx squared, but in this particular problem it's 1/2 kx squared. I mean, it doesn't really matter, but it's just a slight difference. Now, the block in this problem, the block will come to rest when all of its initial kinetic energy has been transformed into the spring's potential energy. Now, at this point, the block is at its maximum displacement from equilibrium. That it's one of its amplitude positions. So that means when K is max, the potential energy of the spring is 0. Now I can show that to you in a picture. It would be easier to. So this is the wall, and here you have a spring of certain K, which is in this case 500 Newton per meters. Now let's assume that this x equals 0, and this is the equilibrium position. At the equilibrium position, K is x is equal to 0, and nothing. There's no force acting on it. But then let's say we disturb the equilibrium, and then we pull this to the right, displacing it a distance x, an arbitrary difference. We're just talking about a general problem. So right here, if you release it from there, the restoring force is going to pull this over there. Restoring force, it's Fr. Now, right here, the U is equal to 1/2 Ka amplitude. That's the maximum amplitude in this system. So at this point, Us is equal to max. That's the maximum potential energy you'll have, since you're displacing it all you can in this particular problem. Now, since there is at this point there's only potential energy, then the total energy, according to the conservation of energy, then we will have no speed at this point. So then that means kinetic energy is minimum, and when the kinetic energy is minimum, in this case it's equal to 0. The total energy, kinetic energy, is equal to 0, meaning that the velocity will equal 0. So now, hopefully this kind of helped you. Now, we're going to start off with the conservation of energy, which states that the initial energy is going to equal the final energy. This is just simply saying that in a system the energy will be constant. Now, on the right side we have no initial potential energy because it's moving at this speed, and then we have a kinetic energy associated with that movement. And on this side we will, when when it's at its maximum displacement from equilibrium, we will have only potential energy, and we will have no kinetic energy, since remember I mentioned when Us is max, K is 0, so K is 0. Now from here it's not a tough problem, I think, because the only variable you want to solve for is this. So let's solve for it. These cancel out, and we're left with this. and you wanted to solve for this, so then you just move this over there, and then you simply take the square root of it. So that being said, the amplitude from the resultant force is going to equal mv squared divided by k. Now let's plug in these values. Two kilograms. Sorry, it's supposed to be 2 kilograms multiplied by 2 meters per second squared divided by k. In this case, k is 500 Newton meters per meter. Sorry on that. Then, if you do this calculation, your velocity, your displacement should be 0.13 meters. So that will be the amplitude when if you have a, let's say you have a spring and then you push it or somehow you move it so that it will have an initial speed of 2.0 meters per second. The amplitude is going to equal 0.13 meters. Yeah. So I hope it helped. Watch it again maybe if it wasn't quite clear, and so you can get the concept. I mean, in these type of problems, the mathematics of it and the algebra is not tricky, but if you have this concept down in your head, you'll be able to solve them easier. Okay, thank you.